Welcome to this special episode of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and today we're going to discuss in-cabin safety systems using radar sensor technology as part 2 of our 3-part series on automotive radar sensors. Here to discuss this with me is Jan Podkamien, Vice President and Head of the Automotive Unit at Vayyar. Welcome, Jan.
Hi, Patrick. Thank you for hosting me today.
So as a 4D radar sensor manufacturer, what applications are emerging for the car for monitoring using radar sensors in cabin?
So the whole in-cabin domain is actually under significant evolution, if not to say revolution. Okay, there is a lot of new improvements on safety as well as additional comfort requirements. There is a lot of new requirements coming in from Euro NCAP and new requirements coming in also from other regulators. And it's a combination, the classic one that everybody is talking about is the child presence detection, which is a new kind of sensor that is not existing. And the idea really is how to create a sensor that will not have any misses on one hand. On the other hand, will not be annoying that people will start ignoring or even disabling. So you want to have something that is really pinpointed, accurate, and giving you the maximum safety, but with a great user experience. And radars are a good way to do that, especially imaging radars, because you can, with the imaging, quantify the dimensions of people and distinguish between adults and infants, and alert only in the case of a child and only a child in the car, either a child that was forgotten or even left intentionally just to go for a few minutes to the supermarket and then it is 30 minutes, or even in the cases where a parked vehicle with open doors has a child coming in. But this is the new kind of child presence detection that is not existing. The question is how to make it interesting in a way that you are not adding more and more sensors and more cost. Because there are other sensors. There is now an extension of the seatbelt reminders becoming mandatory on the rear benches. Until now, you could get Euro NCAP points for the front rows. Now it needs to also have the rear seats. So an additional pressure sensors on each seat, additional cost. Airbag disabling by the mechanical switch, airbag suppression by expensive weight sensors, pre-tensioners of the front seat belts that are also based on the sensors that are providing the seat position. All of those are sensors that have a relatively aggregated high cost, and if there is a magic that you can now have less sensors and provide the same amount of functions, then you are basically adding more safety while also reducing the cost, and which is in a different way of the traditional automotive market. Usually you increase the safety by increasing the cost. And our imaging radar is able to cover the whole cabin and provide all of those functions that we just discussed. Actually reducing the price per Euro NCAP point from about $15 per point to $3 per point, while saving a few tens of dollars to the OEM.
So how are these in-cabin sensors different from the ones used on the outside of the car? Are there different design considerations?
Yeah, absolutely. I think that's one of the interesting myths in this industry, because many people are thinking, that a radar is a radar is a radar. And if you know how to do a corner radar that is transmitting in open air and just, assuming that's pretty empty out there, and if you have one or two or few objects, you get the reflections. First of all, doing imaging is not like doing Doppler, but even then, the in-cabin monitoring is a Faraday cage. The whole cabin is a metal cage, and you have a very small radius. We are not talking about 50 or 100 meters. We are talking about 1.5 meter radius. and there is a lot of multipath, and all those multipaths are very, very tricky because the short ranges actually are pretty hard to separate them from the real reflections. And you have multi of those multipaths because of the cage. So it's a very different development environment. You have the 60 versus 80 gigahertz, which is regulatory dependent, but algorithm-wise, it's a very different approach of design.
The in-cabin ecosystem is evolving. From 2023, Euro NCAP standards will begin scoring child presence detection systems. Vayyar's leading-edge 4D imaging radar-on-chip technology will protect the lives of countless children, while enabling vehicles to receive the full 4 safety points offered by Euro NCAP. The platform supports direct sensing child presence detection that fully complies with the core 10-second detection requirement. It protects babies left behind intentionally or unintentionally, as well as kids who enter unlocked vehicles and become trapped. Crucially, the platform's ultra-wide field of view covers the full length of the cabin, including 3 rows, the trunk, and footwells. High-resolution point cloud imaging enables accurate classification algorithms for children and adults, preventing false alarms and supporting OEMs in the development of child presence detection intervention strategies. It also enables precise cabin perimeter definition, preventing false positives and negatives caused by movement around the vehicle. From 2023, Euro NCAP will award 1 safety point if 2 vehicle rows are equipped with seatbelt reminders, pushing OEMs to implement rear bench seatbelt reminders. This safety feature will also be a mandatory prerequisite for 3 occupant status monitoring points. Vayyar's high-performance in-cabin monitoring platform detects all occupants and classifies them by size to support seatbelt reminders with no alerts for infants and car seats. High angular resolution enables accurate detection, localization, and classification of even 3 passengers seated on the rear bench. By delivering multifunctionality on a single-chip platform, Vayyar reduces vehicle production costs, replacing 5 traditional weight or capacitive sensors. The RFIC can extend support for front passenger classification, enabling FMVSS 208 compliant airbag deployment and disabling. Euro NCAP also awards 2 points for automatic airbag disabling. Vayyar's support of this feature will prevent human error, such as mistakenly placing a rear-facing child seat in the front passenger seat without disabling the airbag. This will also eliminate the error of manually disabled airbags from remaining inoperative. This capability not only saves lives, but also reduces costs by enabling removal of the mechanical airbag switch. Vayyar's multifunctionality on a single-chip platform is enabled by the industry's highest angular resolution and widest field of view, delivering the ultimate in-cabin monitoring. It enables all passenger vehicles, from mini cars to SUVs, to earn up to 7.5 Euro NCAP points with 1 sensor, replacing up to 7 existing safety sensors. The road-ready application combo supports both child presence detection and seatbelt reminders on a single chip. The native 4D point cloud platform architecture supports future application readiness with over-the-air upgrades, increasing OEM's hardware ROI. Vayyar's ACQ100 qualified ASIL-B compliant radar-on-chip solution is production-ready for SOP 2023 programs. It's all set to transform in-cabin safety.
So that was a very interesting demo. Thank you very much. What is the future of applications and how can they benefit from this technology?
The whole idea, at least in Vayyar's view, but we also see that as a significant feedback from the industry, OEMs are shifting to different types of platforms. They are looking for smart platforms, smart sensors that are scalable over time. Basically, if you think about it fundamentally, you want to have less sensors, less direct costs, less wiring, less development, less risky projects. But to be able to do so, you need to have sensors that are very high on the density of the information that they can provide. Okay, and that density is by the coverage area and the resolution and the, in our terms, the pixel size. But at the end of the day, if you have a platform that gives you a very well-defined and very well-filtered 3D image with all the relevant data, from that point on, you can develop an infinite number of features, okay, or additional set of capabilities, or new regulations in the future. So if you think about conceptually, okay, if you have a camera, you just get a clean image, you can do image processing on top of that image, no matter what you are looking at. And the camera maker doesn't really care what they are looking at. On the other hand, the developers don't really care how a camera was really seeing what it's seeing. We are trying to do the same thing on the radar side. Instead of providing a front end that requires now all the industry to be experts on radar and develop algorithms, low-level algorithms, hardcore radar algorithms in that tough environment with the Faraday cage, we are basically providing a full 3D point cloud API. And from that point on, automakers, tier ones and OEMs can develop imaging software either by traditional ways or by machine learning, but they don't need to deal with the unpleasant hardcore radar stuff that your audience is probably very interested on doing so. But the general availability automotive industry, they are not really intending to be radar experts, and they can start developing applications, shortening time to market, adding additional capabilities with a minimal incremental cost because it's software development, while the hardware is already there, validated and installed, and you can even deploy additional capabilities to vehicles on the road.
Well, you've taken a great approach, and I think it'll be widely adopted. Thank you, Jan, for discussing how new automotive radar sensor technology is being used in the in-cabin applications. We appreciate your insightful discussion and look forward to our next episode on radar sensor technology for motorcycles and scooter applications for safety. Thanks, everybody, for watching today.
Cabin safety.